us now consider the following question. It says that given that the number of elements in set A is 20, the number of elements in set B is 30, and the number of elements in the union of A and B is 45, calculate the number of elements in the intersection of A and B. It is important for us to note that if A and B are two sets, then the number of elements in the union of the two sets equals the number of elements in A plus the number of elements in B minus the number of elements in the intersection of A and B. That is, in order for us to find the number of elements in the intersection, we need to know and take this formula into consideration. The formula states that the number of elements in the union of the two sets A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. And we will apply this formula to get our unknown, which is the number of elements in A intersect B. There's also another important formula that we can apply and as it relates to two sets, and we need to know when to use either of these two formulae. Now there's another one that says that the number of elements in the universal set is equal to the number of elements in A union B plus the number of elements in the complement of A union B. So there are times when if the universal set is given and the union, we can also find what is in the complement of the union of A and B. So these are two important formulae that we have to know and know when to apply them. Seeing that we want to find the number of elements in A intersect B, then the first formula is the one that we will be using here. We don't know the number of elements in A intersect B, so we're gonna denote it X. So let me make a note. Let the number of elements in A intersect B be equal to X. Therefore, applying the formula, which is the first one, the number of elements in A union B, we have it to be equal to 45. We're going to form the equation now. 45 is equal to 20, which is the number of elements in A, so that's equal to 20, plus the number of elements in B, which is 30. And then in this case, the equation says minus, so we're going to put minus the number of elements in the intersection of the two sets, which in this case is X. So we can simplify the right hand side a little more if we wish. So we have 45 is equal to, add the two constants, we get 50 minus X. But our aim is to solve for X. And when we solve for X, we must have our coefficient of X being a positive 1. What we can do is to take the X on the other side to make it positive. So basically what we're doing is adding X on both sides of the equation. It will not change the equation in any way. So if you take the X over, we're going to have 45 plus X is equal to 50. And so we can now solve for X because its coefficient is positive and it's positive 1. So X is therefore equal to, so 45 is added to a particular number, gives an answer of 50. What is the number? And as you can see, you know that the answer is upfront 5. So to get it, we have 50, which is the result, minus the 45 in this case, the 45. And so X is equal to 5. So it means that the intersection of the two sets A and B is equal to 5. And that takes care of the question. Let me just show you something here quickly that Because sometimes you look at these and you may say, the numbers are so big that it seems as though it is very hard to believe that the intersection is 5. And when you see, because some persons are going to be adding up, how can you see, some persons are saying 20 plus 30, that's 50, and then the union is that, and then you get all mixed up. But let me just show you quickly the Venn diagram. You have two sets, one is A and one is B. We know that 5 is the intersection of A and B, so 5 goes right here. So this is your set A and this is your set B. Now remember that the number of elements in set A is 20. Now if 5 of the elements that are in A are also in B, it means that over here for A only we will have 15. So if you look at set A, 15 plus 5, that's basically 20. But 5 of the members that are in A are also in B. So when you take out those 5 out of the 20, you end up with 15 alone in A. So this little section is what we call A only. Similarly, set B has 30 members, but of the 30 elements or members, 5 of them also belong to set A. So when you take the 5 from 30, you end up with 25. So if you add these three numbers now, 25 plus 5 plus 15, you end up with 45, and that is why it said the union of the two sets is 45, and that is how the 45 comes about. We do not repeat elements when we talk about sets. So the number of elements in A only is 15. The number of elements in B only is 25. The number of elements in A intersect B is 5. In this case, we're not counting up anything. We don't say the number of elements in set A is 2, 1, 2 by just counting. The only way we count is unless at the beginning of the question the elements were stated as in a list of the elements, but in this case we weren't given a list, and as such we cannot count to say that of course 1, 2, these are the only elements. No, we have to give it in terms of a sum, a total rather, an aggregate. So in this case 15 is the element, the total number of elements in A alone, and 5 is the total number of elements in the intersection of A and B. 25 is the total number of elements in B only. But combining all the three elements, we get the union of the two sets, and that is equal to 45.